Chapter 2, Overview of the Scientific Method. This is an abstract from Psychological Science Journal article. And in this abstract, the researcher raises a question about how taking notes on a laptop affects learning. They note that this topic is important because of the common use of laptops for note-taking and its possible negative effects on learning. So they go like this. Taking notes on laptops rather than in longhand is increasingly common. Many researchers have suggested that laptop note-taking is less effective than longhand note-taking for learning. So that's the introduction part, right? And then it continues. Prior studies have primarily focused on students' capacity for multitasking and distraction when using laptops. So this part, they're talking about past literature. This is also a part of the introduction section. The present research suggests that even when laptops are used solely to take notes, they may still be impairing learning because their use results in shallower processing. In three studies, we found that now here, this part, they're talking about the results and discussion. We found that students who took notes on laptops performed worse on conceptual questions than students who took notes longhand. We show that whereas taking more notes can be beneficial, laptop note takers' tendency to transcribe lectures verbatim rather than processing information and reframing it in their own words is detrimental to learning. Okay, so in this chapter, we will discuss the basic research process, including selecting a research topic, reviewing existing literature, refining the research question, and forming a hypothesis, designing and executing a study, analyzing that data, drawing conclusions, and reporting findings. First section, a model of scientific research in psychology. This figure shows a model of psychology research. Researchers ask questions, conduct studies, analyze data, draw conclusions, and publish results, forming a cycle. New research generates new questions, leading to ongoing research. Questions can also originate outside this cycle from observations or problems, but researchers check existing literature first to see if questions are answered and refine them based on previous findings. The research by Mel and colleagues in 2007, discussed in Chapter 1, exemplifies this model well. Their main question was whether women and the women are more talkative than men, a stereotype influenced by popular claims and prior research. However, upon reviewing the existing literature, they found this question had not been thoroughly examined scientifically. They then conducted a detailed empirical study, analyzed their findings, which revealed minimal differences between women and men, and published their conclusions, adding to the scientific literature. Scientific work continues beyond publication as their study raised new questions about the reliability of the results and possible cultural differences. These questions are likely to be explored further by them and other researchers inspired by their work.
We all know that distracted driving and specifically
Okay, here is another example. As cell phones became the widespread in the 1990s, concerns arose about their impact on driving. Many psychologists studied this scientifically. Previous research showed that simple verbal tasks impair performance on perceptual or motor skills, but no one had specifically studied cell phone use and driving. These researchers compared driving performance with and without cell phones in controlled lab and road tests, finding impairments in hazard detection, reaction time, and vehicle control due to cell phone use. New studies continue to emerge, including research showing that cell phone conversations pose a higher risk than conversations with a passenger who is aware of driving conditions. This means that talking on the phone, regardless of whether hands-free features are used, is not safe. Now, driving while texting is also dangerous, obviously, and not just talking on the phone. Now let's watch the video reporting a study conducted on the street. And I hope you can hear the audio. And just in case you can, I'm going to turn this on, the caption. Okay.
Texting while driving is a major national safety concern. But until researchers with the Texas Transportation Institute conducted a first of its kind study, we didn't know how dangerous it really is. Up until now, published research has been limited to results of texting drivers that were tested using driving simulators. TTI's study examined drivers in an actual driving environment. Here, Associate Transportation Researcher Christine Yeager demonstrates how that research was conducted. There were a total of 42 participants between the ages of 16 and 54 who drove an 11-mile closed course at relatively slow speeds. The participants read and typed a story both in the laboratory and then here behind the wheel. Reaction times to a flashing light on the track were also measured. Researchers discovered that reaction time was doubled when the participants were texting. That's much worse than what the research community thought up until now. And even worse, drivers were more than 11 times more likely to miss the flashing light altogether when they were texting.
What that means is that drivers have only half as much time to respond to sudden events in their driving environment, whether that's a swerving vehicle or a vehicle that suddenly brakes in front of them or even a pedestrian.
Researchers also determined that reading and composing text messages were equally as dangerous. Texting drivers were less able to stay in their lane. Texting drivers were less able to maintain a constant speed. Researchers are quick to point out that this TTI study only hints at the potential problems associated with distracted driving. In the interest of safety, the closed course contained no other vehicles and no hills, or any of the other routine dangers associated with everyday driving.
From this study, we learned that drivers are more likely to swerve in their lane, and even though we tried to ensure safety by only having participants drive at 30 miles an hour and with wide lanes, there were still many close calls. We had participants strike barrels, and it's just really scary to think that this is happening on our public roadways.
The entire 47-page report entitled An Investigation of the Effects of Reading and Writing Text-Based Messages While Driving is available at the link accompanying this video.
Okay, so this study shows that it's not safe while texting and driving at the same time. Okay. All right, next section, finding a research topic. A good research begins with a strong question, but coming up with a good research question does not sound easy. This may be because it's a creative process that is mistakenly seen as almost impossible for novice researchers, while experts seem to find questions effortlessly. Psychological science research shows that this process relies on common thinking and persistence. In this section, we discuss simple strategies for generating ideas, turning them into testable questions, and evaluating those questions to determine if they are interesting and feasible to answer. Finding inspiration. Research questions often start as broad ideas about behavior or traits like talkativeness, learning, depression, or bungee jumping. Before turning these into testable questions, it's helpful to understand their origin. Common sources include informal observations, the practical problems, and past research. Informal observations involve direct or second-hand observations from sources like social media content, news, and books. For example, you may have watched a short clip online showing people being mean to a black person who is blind, but are kind and helpful when they see a white person who is blind. Another example is Stanley Milgram's obedience study. It was partly inspired by news reports of Nazi trials, leading him to explore how ordinary people commit immoral acts under authority. Practical problems often motivate research, including applied studies in areas like law, health, education, and sports. Examples of these problems are whether handwritten notes enhance exam scores, the relative effectiveness of psychotherapy versus medication, how cell phone use affects driving, the safe driving, the best teaching methods for reading, or strategies to help make going to the gym a regular habit. However, research ideas often originate from previous studies as science involves collaboration where researchers build on each other's work. Beginner researchers can consult experienced researchers or review journal articles on topics like perception, bias, or learning. Reviewing the research literature. As discussed in the previous slide, one common source of inspiration is previous research, but reviewing the literature is essential at the early stage of the research process. It involves finding, reading, and summarizing relevant published research, which helps identify new questions and supports your research process. By reviewing the past literature, you can see if a research question has already been answered, and you can evaluate how interesting your research question is. It also gives you ideas for how to conduct your own study and it tells you how your study fits into research literature. There are millions of psychology research articles and books, and it keeps growing. By the way, it does not include self-help, pop psychology books, dictionary entries, websites, or sources aimed at the general public because these sources are not reliable. Reason is simple. They do not go through a rigorous peer review process, but are often based on common sense or personal experience. So they are kind of useless for research purpose. What about Wikipedia? Although it has valuable information, it's not reliable either because anyone can write and edit its contents, as you probably already know. Therefore, when we say research literature, we mean articles in professional journals and scholarly books in psychology and related fields. So, what are professional journals? Professional journals are periodicals that publish original research articles mainly in psychology and related fields. Most articles are empirical research reports or review articles. They are usually monthly or quarterly, with issues grouped into volumes by year. I think almost all journal articles today are available in electronic form, and many are not even available in print form. Empirical research reports detail new studies by the authors, introducing a research question, explaining its interest, reviewing previous work, describing their methods and findings, and drawing conclusions. Review articles, on the other hand, summarize existing research on a topic and often introduce new methods to organize or interpret the findings and give new research ideas. If a review article focuses on theory, it's sometimes called theoretical article. If a review article provides a statistical summary of a multiple past research studies, it's called a meta-analysis article. Most psychology journals use double-blind peer review, where researchers submit manuscripts to an editor, who is usually an established researcher, who sends it to two or three experts. Reviewers critically evaluate the manuscript and send their feedback and publication recommendations back to the editor. The editor then decides to accept, request revisions, or reject the paper. Comments are shared with researchers for revisions, and these comments are sometimes very mean and not constructive or helpful. This process keeps reviewer and researcher identities anonymous, ensuring standards before publication. Some newer open access journals, such as Frontiers in Psychology, adopt open peer review, in which reviewer identities are published alongside articles to promote transparency and accountability. Scholarly books are written mainly for researchers and the practitioners. A monograph authored by one or few authors provides a cohesive topic presentation like an extended review. Edited volumes, edited by a few editors, gather many authors to write chapters on different aspects. While they can offer a cohesive view, chapters may differ in perspective uh, or contain disagreements. Generally, scholarly books are peer-reviewed, similar to professional journals. The primary method for searching research literature is through the use of one or more electronic databases. These include Academic Search Premier, JSTOR, and ProQuest for various academic fields, ERIC or ERIC for education, and PubMed for medicine and related fields. Nevertheless, the most important database for our needs is PsycInfo, which is published by the American Psychological Association, or APA. PsycInfo is a comprehensive database with thousands of journals and books, often covering all psychology research literature, and can be accessed through the NSU library. PsycInfo allows you to find scholarly articles by entering search terms, retrieving records with keywords and standardized index terms such as human sex differences or learning strategies. It offers a thesaurus for help with index terms. With 4 million records, refining searches with multiple terms is often necessary, as a single term might return too many results. Records usually link to full text, or you can request missing ones via interlibrary loan. Campus librarians are available to assist, so if you need to find something, feel free to ask them. Besides entering search terms into PsycInfo and other databases, there are several additional ways to explore the research literature. If you find a good article or book chapter on your topic, check its reference list for other relevant articles, books, and chapters. In fact, if you find a book, be sure to review its reference section. If this section is very extensive, it's likely a good, reliable book. Conversely, if there is a short or no reference section, it's best not to bother reading it. You can also begin with a well-known classic article or book chapter on your subject. Search for it in PsycInfo using the author's name or the article's title, and then connect to a list of related works in PsycInfo that cite this classic piece. This approach is effective because other researchers studying your topic are likely to know about the classic article and cite it in their research. Another way to search literature is to use the internet, such as Google Scholar. This might lead you directly to works in the research literature, like articles in open access journals or posted on researchers' websites. Although a search engine like Google Scholar is especially useful for this purpose, you need to be very careful with the results. As studies have found that it's actually some recent studies found that Google Scholar can display fake scientific journal articles posing as legit peer-reviewed articles. I'm not going to tell you not to use Google Scholar, but if you find a good article through it, verify it by searching through the NSU library database. Finally, talking to your instructor or other psychology faculty members who know about your topic can be beneficial as they can suggest relevant articles and book chapters. When I was a graduate student, my mentors used to give me the latest research articles whenever I visited their offices, as they were aware of my research interest. When conducting a literature review, you might come across hundreds of good sources and feel like you need to include them all. However, not every article, book chapter, or book related to your research idea or question is worth reading or including in your review. Instead, focus on sources that help you achieve four key objectives. A. Refine your research question. While a novice researcher's questions may be vague, unclear, and non-systematic, you can improve them by learning from various sources to formulate better questions. B. Identify appropriate research methods. Research articles include a methods section explaining the detailed procedures. Select a research method that best matches your questions, including how to measure variables and collect data. It's generally recommended to use methods proven effective by others unless you have a really, really good reason to choose differently. C. Place your research in the context of previous research. It's essential to review past findings related to your research questions. And D. Write an effective research report. The best way to improve your writing skills is to practice regularly and use a well-written paper as a model. When looking for relevant research articles, prioritize recent publications. For new topics, recent might refer to articles from the last couple of years, while for less current subjects, it could mean within the past decade. But generally, it is recommended to stay by looking for sources from the past 5 years. The ideal starting point for research articles are review articles on your topic. They offer a valuable overview by discussing key definitions, results, theories, trends, and controversies, helping you understand how your research connects to the existing literature. These articles also provide future research suggestions. Find sources that provide information backing your research question. For instance, if you are examining how cell phone use impacts safe driving, seek data on how widespread cell phone use is, the frequency and cost of motor vehicle crashes, and relevant factors. Finally, how many sources are enough for your literature review? Now, this depends on your topic's scope and objectives. One study suggests that psychology journal articles typically cite around 50 sources on average, depending on your assignments. But I usually do not require my students to include 50 sources for their papers, unless I would say it's a graduate course, graduate research course. However, the criteria for selecting helpful references remain consistent. Next section, generating good research questions. Once you have a research idea, the next step is to develop at least one empirically testable research question. These questions should focus on a single variable or the relationship between variables to make your research study simple. A helpful approach is to examine the discussion section of a recent research article on your topic. This section compares summarized findings with previous research data and often proposes future research directions. These proposals frequently include specific research questions that you can pursue through additional studies. This study is effective because these questions are usually recognized as interesting, important, and meaningful by experienced researchers. Alternatively, you can generate your own research questions. If you have a specific behavior or psychological trait in mind, think of it as a variable and ask about its frequency or intensity. If this question has not been explored scientifically before, it could be an interesting and valuable area to investigate. Often, however, scientific research has already answered how frequent or intense the behavior or characteristic is. If that's the case, consider transforming it into a question about the relationship between the behavior or characteristic and another variable. One way to do this is to ask yourself the following series of more general questions and write down all the answers you can think of. What are some possible causes of the behavior or characteristic? What are some possible effects of the behavior or characteristic? What types of people might exhibit more or less of the behavior or characteristic? What types of situations might elicit more or less of the behavior or characteristic? Generally, each answer you provide can serve as a second variable, promoting questions about their relationship. For example, if you focus on talkativeness, you might ask whether family size affects this trait. Does family size relate to talkativeness? Alternatively, you might notice that people are usually more talkative in same-sex groups compared to mixed-sex groups. Is there a difference in average talkativeness between these group types? This method allows you to generate many empirically testable questions about almost any behavior or psychological trait. When considering a new variable, keep the research design simple, as complex studies can be challenging to conduct. However, what if you find that research question you came up with has already been studied scientifically? Although novice researchers often want to give up and move on to a new question at this point, this is not necessarily a good strategy. Now, think about this. If the research question you want to study has already been published in a peer-reviewed journal article, it means that your question is in fact interesting and worthwhile to investigate. Furthermore, the question can likely be refined to ensure its answer adds new insights to the research literature. Again, considering a series of broader questions about the relationship is an effective approach, such as, are there other ways to define and measure the variables? Are there types of people for whom the relationship might be stronger or weaker? Are there situations in which the relationship might be stronger or weaker, including situations with practical importance? Research often generates more questions than they can answer, requiring criteria to evaluate which ones to pursue and which one to discard. We will explore the way to select good research questions. One is the interestingness of the research question. Research questions should be interesting. For example, consider asking how often people tie their shoes, whether people feel pain when punched in the jaw, or if women are more likely to wear makeup than men? These questions are clearly not interesting. It's important to understand that we are not talking about whether a research question interests us personally. Instead, we focus on whether it interests the general public and the scientific community. Now, let's explore what makes a research question interesting in this context. There are three factors that influence the interestingness of a question. First, research questions that seem to conflict with common sense. This is one of the most important factors for me personally, especially since my research concentration is in cognitive psychology. I always find it interesting when research findings go against common sense. For example, people have believed for decades that boys have better math skills than girls, but recent studies suggest that the difference is much smaller than previously thought, and depending on the type of math skills tested, there are no statistically significant differences between boys and girls. Second, whether or not answering a research question will fill a gap in the scientific knowledge. A key factor in choosing an interesting research question is whether it fills a gap in the literature, meaning it has not been answered yet and is a natural question for those familiar with the research. Third, whether or not its answer has important practical implications. The last key aspect to evaluate when determining if a research question is interesting is whether its answer carries significant practical implications. Another key criterion for research questions is their feasibility, which depends on factors like time, money, equipment, skills, and access to participants. Researchers must consider these to avoid wasting effort on unfeasible projects. Reviewing psychological journals reveals both complex and simple studies. Complex research often involves longitudinal designs, neuroimaging, and multivariable analysis conducted by expert teams with grant support. Lots of money. But simpler studies, such as those with convenience university samples and straightforward tasks, can also yield valuable results. Additionally, it's advisable to use methods successfully employed by others. For instance, to influence moods using proven techniques like paying compliments is a good idea. Such approaches are reliable and maintain continuity with past research, facilitating comparisons and understanding the broader implications. Next section, developing a hypothesis. Before describing how to develop a hypothesis, it is important to distinguish between a theory and a hypothesis. A theory is a bundle of explanations of phenomena that includes unobserved variables, structures, or principles. For example, Zhejiang, Zhejiang, 1965 theory of social facilitation and inhibition suggests that being watched causes physiological arousal, affecting responses based on task familiarity. For familiar tasks, observation boosts correct responses. In contrast, for less practiced tasks, being watched leads to more incorrect responses. This theory, known as drive theory, explains both social facilitation and social inhibition by incorporating concepts like arousal and a dominant response, as well as processes such as how arousal influences the dominant response. Now, outside of science, from daily conversation to true crime podcast, calling an idea a theory often suggests it is untested or just a guess. In science, however, a theory is simply an explanation of phenomena. Good theories are well supported by numerous empirical research results. For example, evolution by natural selection is a theory because it explains the diversity of life, not because it is untested. In fact, evidence overwhelmingly supports it, and most scientists accept it. When a true crime podcast host discusses a theory about a specific murder case, they should say they have a guess, an idea, or at least a hypothesis, not a theory, since they usually lack empirical evidence to support their claims. A hypothesis, on the other hand, is a specific prediction about a new phenomenon that should be observed if a particular theory is accurate. It is an explanation that relies on just a few key concepts. Hypotheses are often specific predictions about what will happen in a particular study. They are developed by considering existing evidence and using reasoning to infer what will happen in the specific context of interest. Hypotheses do not always originate from theories. Some are atheoretical and are created after observations, like a detective forming a hypothesis based on evidence collected during a murder investigation. This is because theories tend to be broad and explain larger uh, data sets. Therefore, if our research question is really original, then we might need to gather data and observe before developing a comprehensive theory. Theories and hypotheses typically follow an if-then format. For instance, if drive theory is accurate, cockroaches should run faster on a straight runway and slower on branching one when others are nearby. Hypotheses can also be formulated as questions, such as, do cockroaches run faster through a straight runway when others are present? Developing hypotheses from theories helps in generating research questions. Researchers often start by developing a theory that explains a set of phenomena, or they may combine existing theories to create a new updated one. From this, they generate predictions or hypotheses about the phenomena, assuming the theory is correct. They then design and conduct empirical studies to test these hypotheses and revise the theory based on the results. This process, known as the hypothetical deductive model, was supported by early psychologists such as Clark Hull, who studied learning theories, and Edward Tolman, who focused on cognition and learning. This process is typically viewed as a cycle where new theories lead to hypotheses that refine or create theories. In contrast, researchers like Skinner, B.F. Skinner, a radical behaviorist, adopted a non-theoretical inductive approach by studying specific cases first, then developing general theories. Okay, now let's examine an example of the Junk's research on social facilitation and inhibition, the drive theory. He developed his drive theory from existing study results, which suggests that being observed during a task causes physiological arousal. This arousal increases the chance of performing the dominant response. According to his theory, social facilitation occurs with well-learned tasks, while social inhibition happens with less familiar ones, which we have already discussed previously. Although his theory provided a clear framework for earlier findings, it still needed testing. He hypothesized that if correct, the presence of others should improve performance on simple tasks but hinder it on more complex ones. In one experiment, the cockroaches either ran along a straight runway, a simple task, or through a cross-shaped maze, a difficult task to reach a dark chamber when a light was shown on them. They did this alone in one condition, or with other cockroaches nearby in another condition. The results supported his hypothesis, backing his drive theory. Researchers also demonstrated that drive theory applied to humans as well. So I guess cockroaches and humans are somehow related. Well, um, when writing your research report or planning your presentation, be aware that there are two main ways researchers typically incorporate theory. The first is to propose a new theory. First, pose a research question, answer it through a new study, and then propose one or more theories to explain or interpret the results. This approach is effective for applied research questions and for questions that existing theories do not address. The second is to re-examine existing theory. This method involves describing one or more existing theories, deriving a hypothesis from one of those theories, testing the hypothesis in a new study, and then re-evaluating the theory. This method works well when there is an existing theory relevant to the research question, especially if the resulting hypothesis is unexpected or conflict with a hypothesis from a different theory. So you may ask, why do we use theories? First, incorporating theories in your research helps shape your ideas for experiments and projects. Second, it adds credibility to your work. Psychologists have explored many human behaviors and developed a number of theories. Relying on these well-established theories can strengthen your innovations as a researcher rather than limit your ability to create original ideas. Next, let's discuss some characteristics of a good hypothesis. A good hypothesis has three key qualities. First, it must be testable and falsifiable. Testability means it can be scientifically tested and evidence can be gathered to disprove it if it is false. If there is only one possible answer, then your hypothesis cannot be tested. Second, logically derived from theories or observations. A hypothesis should be logical and grounded in prior theories, observations, or reasoning, employing deduction when a theory is available or induction when only specific data is present. Finally, it is expressed positively about the existence of a relationship or effect. It should be asserting the presence of a relationship rather than its absence, as science aims to provide something exists rather than disprove it. This approach aligns with the scientific method and underlying statistical principles. Okay, next section, designing a research study. Formulating a hypothesis requires identifying the variables to examine and clearly defining them for measurement. In psychology, research questions focus on these variables. A variable is a characteristic or quantity that can differ among individuals or situations, such as students, the height, or measures, which vary from person to person. It must have at least two levels, like tall or short, representing different states. A variable can have two or more levels, possibly even infinitely many. For example, reaction time measurements, which ranges from 0 milliseconds to infinity. Almost everything can vary except for the speed of light. Variables are categorized as either quantitative or categorical. Reaction time serves as an example of a quantitative variable representing a measurable quantity. It is usually assessed by assigning a numerical value to each individual. Other instances of quantitative variables include how talkative someone is, the level of depression, and the number of siblings a person has. A chosen measure is an example of a categorical variable or nominal data, which represents a quality. It is usually measured by assigning a category label to each person, such as psychology, English, nursing, etc. Other examples include nationality, occupation, whether someone is receiving psychotherapy, and room numbers. Now, room numbers such as room 100 and a room 101 are categorical values. Therefore, just because room 101 has a number that is larger than room 100, it does not mean that it is bigger than the other because it's just the name of the room. Researchers must provide a clear definition of how they will measure the variable. For example, when measuring depression, simply asking participants to describe their feelings in 200 words is too abstract, not a precise measurement of depression severity, and also it makes it difficult to compare results with previous literature. Instead, researchers should translate abstract concepts into observable, quantifiable measures. A well-established tool often used in empirical research is the Beck Depression Inventory. It is advisable for researchers to choose an operational definition that has been widely adopted in prior studies to ensure consistency and reliability. Comparing their results with previous research can also enhance the validity of their findings. Sampling and measurement. In addition to deciding which variables to manipulate and measure and defining them operationally, researchers must also identify their population of interest. In psychology, this usually means making conclusions about a very large group of people known as the population. This could include, for example, all American teenagers, children with autism, professional athletes, all psychology students at NSU, or just humans, depending on the researcher's goals. However, the population can also be small depending on the research question. If your research focuses on a rare disease, the size of your population of interest can become relatively small. But typically, the population size can be quite large, so researchers usually analyze only a small portion or sample of the population. For instance, a researcher might analyze the talkativeness of several hundred university students to draw broader conclusions about men and women. Therefore, it is crucial for researchers to select a representative sample that captures the main traits of the population. Think of it like cooking a large pot of soup. In order to be sure that you cook it right, what do? You taste the sample rather than consuming the whole soup to examine it, right? However, if you do not stir the soup first before taking a sample, it may not reflect the overall flavor. So it's important to make sure that your sample is a good representation of the population of interest. One way to obtain a sample that truly represents the entire population is through simple random sampling, where each number, each member has an equal chance of being selected. For example, a pollster could create a list of all registered voters in a city, which is the population of interest. They then randomly choose 100 individuals from this list and ask them whom they plan to vote for. However, random sampling is often impractical in psychological research, unfortunately, because sometimes researchers do not have enough budget to collect data from a good sample, or they may not have access to well-defined populations. Also, it may not be practical to ensure that all American teenagers or children with autism, for example, have an equal chance of selection. The common alternative is convenience sampling, which includes individuals nearby and willing to participate, such as students in an introductory psychology course. It's convenient because most researchers are teaching at colleges and universities, therefore, they have easy access to their students. However, this method risks non-representative samples, making it less suitable for generalization to the entire population. For example, psychology students tend to be more motivated to learn, younger, and consist of more females compared to the general population. And this can skew the results if the general population is the population of interest. Despite this weakness, overall, many research findings using convenience sampling tend to align with those from better represented samples. Okay, the next step for a researcher is to select a data collection method. As you discover in this course, numerous research approaches exist and can be categorized in different ways. A major distinction is between the experimental and non-experimental research. Researchers seeking to test causal relationship between variables need to use an experimental method. This approach is crucial because it is the only way to determine causality. In experiments, researchers adjust one or more variables while controlling for other factors, then observe how these adjustments affect participants' responses. The ideas of independent and dependent variables are core to experimental research. The independent variable, or IV, is the variable that the experimenter manipulates, acting as the presumed cause, while the dependent variable, or DV, is the variable that the experimenter measures, representing the presumed effect. So the independent variable causes the change in the dependent variable. Extraneous variables are any variables other than the dependent variable. These variables might not cause serious problems unless they act as confounds. Confounds, or confounding variables, are a type of extraneous variable that systematically changes with the variables being studied, providing an alternative explanation for the results. In other words, confounding variables can act like an independent variable without researchers realizing it at the time of the research being designed. When designing an experiment, researchers must control for confounds to prevent extraneous variables from becoming confounding variables. This is super important because to establish a causal relationship, they need to eliminate other possible explanations for the findings. Imagine you are conducting an experiment to investigate the effect of lights on memory. You hypothesize that a brighter environment improves participants' memory. But what if the light bulb you are using in the experiment emits unwanted noise when it's bright? This actually happened with some smart light bulbs we bought from IKEA a while ago, and we are still using some of them. You can clearly hear the noise coming from some of the light bulbs when it gets brighter. Anyway, in this experimental study, the independent variable is the brightness of the room with the light bulb. And there are two conditions or two levels of this independent variable. One is bright and the other is dim. Now, please note that in this example, we only have a single independent variable, the brightness level, with two levels, bright and dim. So I don't want you to get confused into thinking we have two independent variables because whether it's an independent variable or dependent variable, you need at least two levels. So each independent variable, uh, uh, each variables, whether or not it's an independent variable or dependent variable, you must have at least two levels. Now, participants are randomly assigned to one of the two conditions. Then they will be asked to memorize items and their memory will be tested later. Let's say the obtained data suggests that participants in the bright condition performed worse than those in the dim condition. However, during the data collection, you as a researcher noticed that the bright light bulb, but not the dim one, was emitting a noise, which you did not realize when designing the experiment. Since this noise was an accidental variable, not planned for, and it occurred in one condition but not in the other, it is a confounding variable because it was not controlled by the researcher. And also, it is affecting your results. You may find a statistically significant difference between conditions, but you cannot conclude whether it's due to the amount of light, the confound, which is the noise coming from the light bulb, or a combination of both. Confounding variables interfere with our ability to determine cause and effect relationships between variables. However, if noise exists regardless of whether the lights are bright or dim, it is an extraneous variable and generally does not threaten our conclusions. This is because only variables that systematically change with the independent variable can provide alternative explanations for the results. Another example of an extraneous variable you can disregard is gender. As long as the number of males and females is roughly equal across all conditions, this variable will not pose any problems. So therefore, the gender does not become confounding variable. So in experimental research, researchers manipulate the independent variable, which influences the change in the dependent variable. In non-experimental research, on the other hand, researchers do not manipulate any variables. Researchers interested in describing characteristics, relationships, and predictions can use non-experimental research. This approach involves measuring variables as they naturally occur without manipulation. For example, recording traffic fatalities involving cell phones last year, or observing drivers' genders and cell phone use at an intersection to see if men or women are more likely to use phone. These are non-experimental studies because the variables tested are not manipulated by the researchers or have already occurred by the time of data collection. These methods include surveys, correlational studies, and longitudinal studies. Non-experimental research is scientific and it can describe and predict, but cannot establish causality, unlike experimental research. Now, this limitation does not make non-experimental research less valuable than experimental research. This is because there are research questions that cannot be answered using the experimental research method or are unethical to address using this type of method. For example, consider the question of whether personality development is influenced by genes, environmental factors, or a combination of both. Identical twins are usually used in this type of study, but in experimental research, twins must be randomly assigned to different families at birth, which is obviously unethical. Another example would be assessing how smoking affects cancer. You cannot ethically randomly assign participants to two groups, one of the two groups, and force one group to smoke 24 hours a day for 20 years while making the other group not smoke for 20 years. Additionally, we would need to monitor them constantly to ensure they follow our instructions, which is neither ethical or nor practical. Although non-experimental research cannot establish causality, some non-experimental methods, such as longitudinal studies, can get close to establishing causality. In this type of study, data are collected from the same group of participants over weeks, months, or even years or decades. This approach allows researchers to observe when variables appear on the timeline, enabling them to speculate about the causation. For instance, some participants may start smoking while others do not, right? And 10 years later, more smokers than non-smokers in this study, in this longitudinal study, may receive a cancer diagnosis. This suggests that although other variables may be in play, researchers can speculate that smoking might have caused cancer. This result can inspire experimental studies with animals, since you can conduct experimental studies with humans. So researchers may conduct experimental studies with animals, which have fewer ethical restrictions than human research. So researchers can examine causality with animal studies to see if it can be established. What about the difference between laboratory and field studies? A laboratory study is a research conducted in a lab setting. In contrast, a field study is conducted in the real world within the natural environment. The laboratory experiments typically have high internal validity. Internal validity indicates how confidently we can determine a causal link between variables. Laboratory experiments typically provide high internal validity because researchers manipulate one variable while controlling all others. When only the manipulated variable varies between groups, effects can be confidently attributed to it. Researchers can ensure high internal validity by removing all potential confounding variables they identify. Generally, the greater the control in the study, the higher the internal validity achieved. External validity concerns the applicability of findings to real-world situations. For example, after testing a new learning method in a controlled lab environment, the next step is to determine whether it remains effective in real-world conditions where variables are uncontrolled. Field research conducted in real-world settings has less control over extraneous variables, possibly including confining variables, which reduces internal validity and makes causal conclusions less reliable. So, what's the point of conducting field research studies? The main goal is to increase external validity. This type of research design is used when researchers prioritize external validity or are interested in how well the research findings can be applied in real-world settings. Usually, there is a trade-off between internal and external validity. So the focus is not on whether the lab experiment is superior to field research or the other way around. If your priority is internal validity, which most researchers favor, you should conduct a lab experiment. Conversely, if you are more interested in generalizability, field research is the better choice. Although some field studies are non-experimental because they do not involve manipulation, others are field experiments where an independent variable is deliberately manipulated in a natural environment with controlled extraneous variables. The overall quality and the level of control over these extraneous variables determine whether such field experiments possess high external validity, high internal validity, or both. The lost letter study is a classic example of a field experiment. Stanley Milgram and colleagues in the 1960s aimed to explore whether participants would mail a stamped letter found on the ground in different public locations, depending on the envelope's address. These letters were intended for four different recipients: medical research associates, friends of the Communist Party, friends of the Nazi Party, or a private individual. So the recipient is the independent variable, and it has four levels or four conditions. The dependent variable was whether or not the letter would be picked up and mailed by the people on the street. Milgram and colleagues discovered that the chances of the letters being returned were lower when addressed to groups they might oppose. Only 25% of letters to the Communist and Nazi parties were returned, compared to about 72% to the medical research group and 72% to the private individual. This shows that people were less willing to mail letters to organizations that they supposedly did not support. Next section, analyze the data. After completing the study and recording observations, researchers need to analyze the data and draw conclusions. This typically involves using both descriptive and inferential statistics. Descriptive statistics summarize the data, while inferential statistics allow researchers to generalize findings from the sample to the larger population. Additionally, inferential methods are employed to assess whether the evidence supports, contradicts, or indicates the need for modifications to a theory. Descriptive statistics. This type of statistics is used to describe a data set by organizing and summarizing it. They include percentages, measures of central tendency, such as mean, median, mode, as well as measures of dispersion like range, standard deviation, and variance, along with correlation coefficients. Mean, median, mode are measures of central tendency that identify the typical or average value in the center of a score distribution. The mode is the most occurring score, and the median is the middle value, and the mean is the um, arithmetic average score of the distribution. Range, standard deviation, and variance measure dispersion. They are a type of descriptive statistic used to assess how spread out a set of data points is. They help determine whether scores are tightly clustered around the mean or if there is a lot of variability. In other words, if the standard deviation is small, for example, the bell-shaped curve of the distribution looks skinny. If the standard deviation is large, the bell-shaped curve of the distribution looks wider. The range is a simple measure of dispersion that simply shows the difference between the highest and the lowest scores in a distribution. So if, for example, the highest score is 10 and the lowest score is 1, 10 minus 1 would be 9. So that's the range of this data set. Standard deviation, or SD, provides a more advanced measure indicating the average amount scores differ from the mean. The standard deviation can be negative or positive. The variance is simply the square of the standard deviation, also measuring how far scores are from the mean, but expressed in different units. Typically, in experimental research studies, means and standard deviations are calculated when an independent variable is manipulated to create two or more groups, and a dependent variable is measured quantitatively. The means for each experimental group or condition are computed separately and then compared to determine if they statistically differ from each other. In known experimental research, simple percentages can be used to illustrate the proportion of individuals engaging in certain behaviors or beliefs. However, more typically, researchers analyze the relationship between two variables through correlation. A correlation coefficient measures the strength and the direction of this relationship, with values ranging from -1, indicating the perfect negative the relationship, to +1, indicating a perfect positive relationship. A value of 0 signifies no association between variables. Now, good example of a positive correlation is the relationship between height and weight, As height increases, weight tend to increase as well. Now, this means that if height decreases, weight also tends to decrease. In a positive correlation, both variables point in the same direction. If one variable increases, the other variable also increases. If one variable decreases, the other variable also decreases, and it's still positive correlation. So I want you to use your fingers, the actual fingers, to demonstrate this. Each hand represents a different variable, and when the finger is pointing up, that means that the variable increases, right? If the finger is pointing down, that means that the variable decreases. So using two hands, when both fingers are pointing in the same direction, whether or not it's up or down, you are describing a positive correlation. Negative correlation coefficients show that when one variable's value rises, the other's value tends to fall. For instance, there is a negative correlation between the amount of exercise and depression. As the amount of exercise goes up, the depression generally goes down. So, in negative correlation, if one variable increases, the other variable decreases, and vice versa. They go in opposite directions. When one finger points up and the other finger points down, you are describing a negative correlation. Next, inferential statistics. As discussed earlier, researchers analyze a sample from a population of interest to extend their findings. Since the data are not from the entire population, they must use inferential statistics to estimate the characteristics of the whole group, the population. Relying on a sample data, they depend on probability, which means they cannot definitely prove their claim, but they can still support it with high confidence. Researchers use inferential statistics to assess whether effects are significant, meaning unlikely due to chance and likely real. Results with less than 5% chance of error are considered significant, allowing generalization from sample to population. If the chance exceeds 5%, the result is not statistically significant. Statistics are inherently can I say this? Probabilistic, enabling researchers to determine if results are unlikely due to chance, but they do not provide absolute certainty. When we refer to an effect as statistically significant, we expect it to be genuine and observable in the entire population. Conversely, if the result is not significant, we assume no effect exists. The 5% threshold is designed to enhance the likelihood of making correct decisions and to ensure that observed significance corresponds to actual effects. For this reason, when researchers discuss research results, they will not say, our results are the proof that A causes B. Rather, they say, our results suggest that A causes B. So researchers cannot say they have proof because mistakes can happen in inferential statistics. There are two types of such mistakes. The first one is type 1 error. This is a false positive that occurs when a researcher claims a significant effect that is not real, just due to chance. Using a 5% threshold, they have a 5% or less chance of this error. Lowering this threshold reduces type 1 errors but increases the risk of type 2 errors or false negatives. In other words, researchers may mistakenly find a significant difference even when there is no actual difference between the conditions being compared. By the way, this is a statistical error because we use inferential statistics to analyze sample data. Statistical mistakes can always happen as long as we use inferential statistics. Type 2 error occurs when a researcher fails to detect a real effect, mistakenly concluding that results are not statistically significant. This often happens if the significance threshold is set too low, such as at 1% instead of 5%, or if the sample size is too small. In other words, the measurement researchers used was not sensitive enough to detect the significant difference. So, even though there was in fact a significant difference between the conditions, they failed to detect it. It's kind of like they are trying to find a tiny ring in a completely dark room with a very dim flashlight. They failed to find it not because the ring is not there, but because the flashlight was too dim. All right, next section, drawing conclusions and reporting the results. Drawing conclusions. Since statistics are probabilistic and the findings can reflect errors, a single study cannot confirm a theory. Rather, theories go through a rigorous process where they are supported, refuted, or modified based on research results. If results are statistically significant and align with the hypothesis and theory, the theory is supported. This indicates it made an accurate prediction and explains a new phenomenon. If a hypothesis is systematically disconfirmed, the theory is weakened, having made an inaccurate prediction and not accounting for a new phenomenon. Although this seems straightforward, there are some complications. First, as discussed previously, confirming a hypothesis can strengthen a theory, but never prove it. Scientists avoid using the word proof, because it is possible that the results may reflect a type 1 error. Other theories may imply the same hypothesis, or new tests might disconfirm the hypothesis. No matter how many confirming cases, disconfirming one could appear. Therefore, scientists see theories as always open to revision based on new observations. Second, a disconfirmed hypothesis might be the result of a minor, unstated assumption of the theory not being satisfied. Strictly, disconfirming a hypothesis disproves its originating theory, but scientists usually do not abandon their theories easily. This confirmation might result from a type 2 error or faulty research design. Maybe they failed to manipulate or measure variables properly. This confirmed hypothesis might also mean that a minor assumption of the theory was unmet. For instance, if Zajong and colleagues who conducted the cockroach study did not find social facilitation in roaches, they might conclude that the drive theory still holds, but only for animals with complex nervous systems. Evidence can refine theories, but researchers must address disconfirmations by improving designs or changing theories. If not, they must replace theories with more successful ones. Ultimately, because statistics are probabilistic and no studies are perfect, there is no such thing as scientific proof. Rather, we have only evidence. Okay, I believe this is the last slide. Reporting the results. Results are typically reported in peer-reviewed journals or presented at conferences, the professional conferences. The final step in the research process is to report the results. As mentioned in the section on reviewing the research literature in this chapter, results are usually published in peer-reviewed journals and presented at conferences. The most respected method for sharing one's findings is to write a manuscript and have it published in a peer-reviewed scientific journal. Manuscripts in psychology journals typically need to follow the APA style. Another way to report findings is by writing a chapter for an edited volume. Ideally, the chapter is peer-reviewed by the editor, but this does not always happen as some editors ask scientists to contribute chapters without a peer review. Presenting at a conference is valuable experience for researchers, especially for students. It can be done as either an oral talk or a poster presentation. The oral presentations involve speaking in front of fellow scientists with talks lasting from 10 minutes to an hour, followed by a Q&A. Poster presentations require summarizing the study on a large poster and highlights the purpose, methods, results, and discussion. The presenter stands by their poster for about an hour, answering questions from visitors. Presenting at the conference offers a great opportunity to get feedback from peers before submitting to the more formal peer review process of journal publication. Okay, so this is the end of chapter 2.